NASA gave a fundamental understanding of Pluto that challenges common perceptions. What is NASA proposing here? Are they inferring the latest findings from the New Horizons space probe, which shows that strange phenomena are occurring on Pluto's surface? One of the most startling images shows what appears to be something drifting across Pluto's outer layer. This raises disturbing questions about whether some form of advanced, dark life exists on this distant world, or if we are dealing with a recognized, yet misunderstood geographical feature. Pluto may not be a planet, but the stories it holds to tell are significant and full of surprises. When Pluto's planetary status was revoked in 2006, scientists were unaware of the data from the New Horizons probe, which had just reached Pluto after years of travel. Since then, we have realized that there is more to this small object than was previously expected. How did astronomers come to deny Pluto its planet status, something we've all grown up with? This occurred after the discovery of several other small planets in the Kuiper belt. They concluded that there needed to be a clear distinction between what constitutes a planet, a dwarf planet, or a trans-Neptunian object. Pluto's size and round shape helped it score points as a planet, but it shares its orbit with several other objects, making its orbit imperfect. This was the main defense for why Pluto was no longer considered one of the major planets in the solar system. Many people were upset by this decision, and letters of protest were sent to NASA from prominent scientists who supported Pluto's planetary status. Even governmental organizations received requests from citizens asking for Pluto to be reclassified as a planet. This planetary status had been with us since the 1930s, and it was a crucial part of the group of 9 planets. It was an established idea. In 2015, when New Horizons sent us the first real images of Pluto, it was a significant moment. It was the first time humanity had seen Pluto up close in such vivid detail. Prior to this, images of Pluto in textbooks and school materials were artistic depictions, not actual photographs. The images sent back by New Horizons defied earlier depictions and even the verified images from the Hubble telescope, providing a clearer view of Pluto's surface. New Horizons allowed us to see Pluto as it truly is, amazing, well-structured, and, intriguingly, with a heart. Since then, Pluto has gained even more fans, and perhaps one day, space experts will change their views, and we may see Pluto reinstated as a planet. The first guaranteed pictures of Pluto were breathtaking. When the first data from the New Horizons probe reached mission control in 2015, everyone present knew they were about to witness something extraordinary. The computers on Earth assembled this captivating image from vast amounts of data. What the probe revealed about Pluto was a discovery that completely altered our understanding of this distant object. Pluto is far more dynamic, better organized, and more alive than planetary scientists had previously thought. Additionally, the little planet appeared to have pleasant features and possibly even more regular peculiarities than expected. With each new piece of information that New Horizons provided, the once faint and lifeless world in the dark reaches of the Kuiper belt began to reveal itself as a place full of life and surprises. Pluto became an intriguing world with extraordinary ice formations, deep valleys, and smooth, cold surfaces. It challenged earlier expectations of a dead, frozen planet. The assessment of data, photos, and revelations continued over an extended period, as it took a long time for the information to travel from Pluto to Earth. Since 2015, we have been astonished by new perspectives of Pluto. One such perspective, shared in 2016, showed what appeared to be someone walking on Pluto's surface. This astonishing moving image showed honeycomb-shaped snowflakes. These ice formations, unlike those on Earth, are made of nitrogen and methane. Researchers identified the floating ice as a solid piece of nitrogen, which formed geographical structures, pushing the blocks upwards and creating honeycombs and fields that looked like wandering mountains. This discovery suggests a warm core deep within Pluto. There seems to be a nitrogen supply several kilometers beneath Pluto's surface, pushing solid blocks upwards and causing these honeycomb formations. This could imply that Pluto has a warm internal center, possibly with pockets of liquid beneath the surface, resembling oceans or magma. The geology team from the New Horizons mission, led by William McKinnon, compared this internal structure to a large-scale geological feature like Hudson Bay in Canada. Virtual models have shown that the striking scene has developed over hundreds of years and remains uniquely active. The particular X pattern in the image is thought to be caused by sublimation, a process where substances change directly from a solid to a gas, and the liquid stage evaporates. The extreme temperatures on Pluto result in geological cycles and natural eccentricities that make the planet seem alive. Christmas in the snow on Pluto might sound insane, but it's a reality. Pluto's climate, as revealed by New Horizons, includes a thin layer of nitrogen, methane, and carbon monoxide, which changes drastically depending on its distance from the Sun. These shifts affect both the environment and surface conditions. Pluto experiences snowfall, but not of water. Instead, nitrogen and methane snow accumulate due to the planet's low temperatures. These elements cover the surface, shaping the landscape and driving other geological processes like cold movement and possibly cryovolcanic activity. These seasonal changes are closely tied to atmospheric pressure. When Pluto is closer to the Sun, the light warms the atmosphere, causing it to expand. As it moves farther away, the atmosphere cools and contracts. This phenomenon leads to nitrogen and methane snow, adding to the planet's dynamic surface. The variations in surface brightness and the distribution of cold deposits further suggest that Pluto's surface features are linked to these environmental cycles. Pluto's mountains are not made of rock but of ice, which is much more flexible than rock. This means Pluto's surface moves much more than Earth's. What does Pluto's heart contain? It turns out that Pluto's heart isn't just a warm image. This region is one of the most fascinating areas of Pluto. Previously called Sputnik Planitia, the region is named after the first artificial satellite, Sputnik 1. This vast, heart-shaped ice surface covers around 1,000 kilometers and is mostly made of nitrogen ice, with traces of frozen methane and carbon monoxide. The bright surface of Sputnik Planitia contrasts sharply with the darker, more complex areas around it. Geographically, this area is a huge impact structure, likely modified by volcanic activity. Unlike volcanic activity on Earth, where magma rises from the interior, Pluto's volcanism involves cold materials rising to the surface, where they freeze and form unique structures. Sputnik Planitia is remarkably level, suggesting that the frozen surface is constantly renewed by internal processes. Scientists believe that there may be liquid water beneath the ice sheet of Sputnik Planitia, kept liquid by internal heat from Pluto. This raises the possibility of life existing in Pluto's subglacial ocean. But how likely is this? The role of Pluto's largest moon, Charon, is also important. Discovered in 1978, Charon is incredibly large in comparison to Pluto, with a diameter about half of Pluto's. This has led to a significant connection between the two bodies, as they are tidally locked, meaning they always show the same side to one another. Charon's surface is also unique, with huge cliffs and massive impact craters. Researchers believe that Pluto and Charon may have exchanged materials in the form of comet-like objects. Pluto, once considered the 10th planet in our solar system, has long captured the imaginations of astronomers, scientists, and the public. Discovered in 1930 by astronomer Clyde Tombaugh, it remained a symbol of planetary exploration and mystery. In 2006, the International Astronomical Union, IAU, reclassified Pluto as a dwarf planet, sparking debates and discussions. Despite this change, Pluto continues to captivate scientists and enthusiasts who are eager to learn more about this far-off object at the edge of our solar system. NASA's renewed investigation into Pluto's true essence, encapsulated in the phrase "Pluto isn't what you think," has drawn renewed attention to its complex nature. This phrase, often accompanied by compelling insights into Pluto's intricacy and importance, hints at discoveries that continue to emerge through NASA's ongoing missions. Through the New Horizons mission, we are learning more about Pluto than ever before. This article explores the latest discoveries and the growing understanding of Pluto as a planetary body, examining how NASA's research is reshaping our perceptions of this mysterious world at the far reaches of our solar system. The exploration of Pluto, particularly through NASA's New Horizons mission, continues to unveil mysteries that challenge everything we thought we knew about this distant object. As the probe passed by Pluto in July 2015, it sent back unprecedented images and data, reshaping our understanding of the dwarf planet. While earlier research mostly considered Pluto as a small, cold, and barren world, New Horizons provided evidence that Pluto is a far more complex and dynamic body than previously imagined. This discovery has ignited debates and sparked a renewed fascination with Pluto, prompting scientists and the public to reconsider its place in our solar system. One of the most intriguing aspects of Pluto is its surface features. New Horizons revealed a landscape that was not the dead, frozen, cratered world that many had expected. Instead, Pluto's surface was found to be covered with vast plains of nitrogen ice, complex mountain ranges, deep valleys, and smooth, rolling hills. These features suggested a dynamic geological history, marked by cryovolcanism, volcanic activity involving the eruption of volatile substances like water, ammonia, and methane, surface reshaping, and possible internal heat. The ice on Pluto's surface is mostly composed of frozen nitrogen, but it also contains methane and carbon monoxide. The variation in surface characteristics points to a history of tectonic activity and geological processes that we typically associate with much larger planets. One of the most striking discoveries was the heart-shaped region on Pluto's surface, known as Sputnik Planitia. This area, which is about 1,000 kilometers across, is made mostly of nitrogen ice and has a relatively smooth surface, suggesting that it is constantly being reshaped by internal processes. The heart-shaped feature is part of a larger impact basin, and its uniform appearance is likely the result of an ongoing cycle of freezing, sublimation, and reformation of ice. This suggests that Pluto's interior may be warm enough to sustain the flow of materials beneath the surface, providing the potential for an ocean of liquid water beneath the icy crust. Such a discovery raises tantalizing questions about the possibility of life in these subsurface oceans, a concept that had previously been considered improbable on such a small, distant world. The presence of geological features like mountains and valleys further complicates our understanding of Pluto. Some of the mountains on Pluto are as tall as 3,500 meters, and they appear to be composed of water ice, not rock, which is highly unusual for a body so far from the Sun. The fact that Pluto has such large ice mountains and diverse surface features suggests that the dwarf planet may have a complex internal structure with heat sources capable of driving geological activity. Researchers hypothesize that Pluto's interior may still be warm enough to sustain some form of liquid beneath its icy shell. This warmth could be generated by radioactive decay or by tidal forces from its large moon, Charon, which could be influencing Pluto's interior through gravitational interactions. Another fascinating discovery was the detection of a thin atmosphere surrounding Pluto. While Pluto's atmosphere is incredibly tenuous, composed mostly of nitrogen with traces of methane and carbon monoxide, its behavior appears to change depending on the planet's distance from the Sun. As Pluto moves closer to the Sun during its 248-year orbit, its atmosphere expands and becomes slightly thicker, while it contracts and freezes as it moves farther away. This dynamic atmospheric cycle is another indicator of Pluto's active nature. The New Horizons mission also revealed that Pluto's atmosphere is capable of producing hazes, which could be formed by complex chemical reactions in the upper layers of the atmosphere. These hazes scatter sunlight and create a reddish tint to some parts of Pluto's surface. Charon, Pluto's largest moon, plays a crucial role in the dynamics of the Pluto-Charon system. The two bodies are in a mutual tidal lock, meaning that they always show the same face to each other. Charon is much larger than Pluto's other moons, and its size and proximity to Pluto lead to significant gravitational interactions between the two. This tidal locking results in a situation where Pluto and Charon exert significant forces on each other, influencing their geological processes. Charon's surface is starkly different from Pluto's, with massive cliffs and impact craters, some of which are believed to have been formed by Pluto's tidal forces. Additionally, Charon's surface is thought to have been shaped by ancient geological activity, including cryovolcanism, and there are indications that it may have once had a subsurface ocean, much like Pluto. The discovery of a potential subsurface ocean on Pluto, or the possibility that liquid water might exist beneath its icy crust, has profound implications for our understanding of habitability in the solar system. While life as we know it may not exist on Pluto, The presence of liquid water in the past or present raises intriguing questions about the potential for life on other icy worlds in the outer reaches of our solar system, such as Enceladus or Europa. These moons, like Pluto, are thought to have subsurface oceans, and studying their similarities and differences could provide important clues about the conditions necessary for life to exist beyond Earth. Pluto's peculiar orbit also adds to its uniqueness. Unlike the more circular orbits of the major planets, Pluto's orbit is highly elliptical, meaning that it moves closer to and farther from the Sun in a way that causes dramatic changes in its surface conditions and climate. This eccentric orbit contributes to the seasonal cycles on Pluto, which can have a profound effect on its atmosphere, surface, and geological activity. These changes are particularly interesting because they suggest that Pluto's environment may be more dynamic than previously thought. For instance, the phenomenon of nitrogen snow, which falls as frozen nitrogen from the atmosphere onto the surface, has been observed by New Horizons. This snow is not made of water, as we might expect from Earth's snow, but rather from nitrogen, which freezes and accumulates in the cold temperatures of Pluto's surface. The ongoing study of Pluto's surface, atmosphere, and internal structure is transforming our understanding of what constitutes a planet and what life-supporting conditions might exist on distant worlds. The data sent back by New Horizons has provided a wealth of information, but there is still much more to learn. The probe's journey past Pluto was just one step in a broader mission to explore the outer reaches of the solar system, and scientists are now turning their attention to other objects in the Kuiper Belt and beyond. The exploration of these distant worlds offers a chance to learn more about the formation and evolution of our solar system, and about the processes that shape planetary bodies over billions of years. Looking ahead, future missions may continue to explore the mysteries of Pluto and its neighbors in the Kuiper Belt. There is still much we do not know about this distant region, and new missions could help to answer some of the fundamental questions about Pluto's geology, atmosphere, and potential for harboring life. One such mission could involve sending a lander to Pluto's surface to study its composition up close, or even sending a probe to investigate one of Pluto's moons, such as Charon, which could reveal further secrets about the Pluto-Charon system. As our technology improves and our understanding of the outer solar system grows, the mysteries of Pluto and the far reaches of our solar system may be unlocked.